Hello, everyone. It is Thursday, May 21st, 2020. We're on week 7, module 3, and this actually is our last new module of the year. So you may not know this, but next week you'll have the opportunity to catch up on some of the missing modules if you've missed any. If you've done every single one every day, then this is your last time to take math this year. So congratulations, and let's get through this together. All right, we are still going to be using our 30, 60, 90 triangles today, but we're going to do them in application situations. So not just one triangle in some situations. All right, so as usual, have Teams open, YouTube, join pd.com. Be ready to go to Edge Elastic and take that mastery check. Remember that mastery check is for a grade. A lot of you guys are missing out on a easy chance at an A by not taking that mastery check. So take your mastery check at the end of class, please. Multiplication chart and a pencil and paper for some scratch work. So hopefully you have all that. So here's do now question number 1. There's only 2 do now questions today, so you have more time to work on other things. If you're stuck on this one, there is a little refresher right here you can click. And so try this one on your own, and then if you get it, that's great. And then press play again to see if your answer and mine agree. If you are stuck, you can also press play to see how I'm doing it if you're stuck. But either way, press pause now and try this one on your own. Can you find X and Y on your own? Maybe using Thelma, the 30, 60, 90 triangle from Tuesday, or whatever you named your 30, 60, 90 triangle. So now try that on your own, and then press pause to try it on your own, and then unpause when you are ready. Okay. I hit a secret Thelma right over here. So I'm going to bring Thelma over to this area. And we've got some workspace down here, so we'll use that. But we can go ahead and find X first. That's fine. So we'll work to find X. Let me get my purple pencil or pen. And so let's look at X. X is the hypotenuse. And 24 is the only side I know so far, and that is the short leg. So if I go 24 over x, then that means I'm setting up a proportion of short leg to hypotenuse. So then let's just look at Thelma here. Thelma will set up her short leg to hypotenuse as well. Go ahead and get the purple or the orange. I think the orange is useful in this situation. So Thelma's short leg is 1, and her hypotenuse is 2. So we're going to go ahead and set up 1 over 2 right here. Now that we have that, it's a pretty straightforward cross multiply and solve. 24 times 2 is 48. X times 1 is x, and x is actually all by itself now. So we've got x. X equals 48. All right, let's go ahead and find y now. Y is the long leg. So I'll go ahead and go 24 over y. And that gives me the relationship of the short leg to the long leg. All right, so then let's look at that same situation with Thelma, short leg to long leg. And again, Thelma's short leg is 1. Her long leg is the square root of 3. So we want to have 1 over square root of 3 here for Thelma so that we can have that same relationship of short leg to long leg. Now we cross multiply 24 times the square root of 3. We just have to leave that as 24 square root of 3. 1 times y is equal to just y. So that's it. Y equals 24 times the square root of 3. Hopefully you got that one. All right, this one will be a little more challenging, but we can still do it. We notice that it is a 30, 60, 90 triangle, 30, 60, 90. This time we've been given which side? Well, it's not the short leg, and it's not the hypotenuse, must be the long leg. So we need to get a Thelma oriented the same direction here, so let me go ahead and find one. Well, I was struggling to find a Thelma that was oriented the right way, so let's just go ahead and draw one here, because I know, unfortunately, some of you guys have thrown yours away. So I'm trying to draw a short leg, the same way as the short leg in that triangle there, a long leg, the same way as the long leg there, and then the hypotenuse, the same way as the hypotenuse here. And if you remember right, and you can look at the Thelma above if you need to, but when the 60-degree angle is over there, the side opposite that is the long leg, and that is the square root of 3. The short leg, which is opposite the 30-degree angle, is just 1, and the hypotenuse was 2. So that's what you should have drawn. Hopefully you drew that. So from that, we can make our proportions down below in the next slide here. So again, hopefully you had your Thelma handy, but if not, we can be okay here. So let's go ahead and I'll start with x. I notice that x in the triangle I'm looking for is the short leg, and they've given us the long leg. So I'm going to go ahead and go with x over 12, which is a relationship of short leg to long leg. Okay, so short leg to long leg in the triangle they've given us. Now I'm going to get the same relationship from Thelma. Thelma's short leg is 1, long leg is square root of 3. So we're going to go ahead and just set it equal to 1 over the square root of 3. So now we've got to cross multiply and solve on this one. X times the square root of 3 is just x square root of 3. 12 times 1 is 12. To get our x by itself, we are going to need to divide by that square root of 3. Divide by square root of 3. That cancels it out over here, which is nice, but it does leave us with x equals 12 over the square root of 3. And if you remember correctly, that's a correct answer, but we do not want to have a square root in the denominator. So we're going to go ahead and take 12 square root of 3, and we will multiply it times the square root of 3 over the square root of 3, which leaves us with 12 square root of 3 over, again, that's the square root of 9, but the square root of 9 is just 3. So 12 square root of 3 over 3. And since both the 12 and the 3 are outside of the square root sign, that'll give us just 4 square root of 3. So that is why we did that. So we got, get my purple marker back. We've got 4 times the square root of 3 is our x. 4 square root of 3. Now, many of you recognize, if you already see the relationship, remember, if you know the short leg, to get the hypotenuse, you just got to double the short leg. So now that we've found out that the short leg is 4 square root of 3, many of you guys are just able to just double it to get the hypotenuse, if you recognize that relationship in Thelma. But if you're struggling with that at all, let's just go ahead and we'll set it up. And so we'll go ahead and go, this time we want y. And so I'll go with, there's all kinds of ways you can do this here, but I'll go y over 4 square root of 3. This is the fastest way to go about it now. So y is the hypotenuse. 4 square root of 3 is the short leg. So let's set up the same thing here for Thelma, the orange. And that equals, oh, that's kind of like a peach-ish color there. Let's get orange. So hypotenuse over short leg will be, for Thelma, 2 over 1. So we've got 2 over 1 here. Now we can cross multiply. Y times 1 is just y. 4 square root of 3 times 2 equals 8 times the square root of 3. And that's it on that one. So now we have y as 8 times the square root of 3. Were you able to get that right? It's pretty tough stuff. As we wrap up e-school, you guys are getting into some pretty complicated, challenging pieces of algebra, how algebra and geometry come together. And if you're getting that right, that's great. If you're not and you're still struggling, that's okay. We'll keep working on this. So with that, we are going to go into some celebrations here. Some of you from other schools may have noticed that the only people that have won the spinning wheel so far have all been from Montview. Part of that is, I think, because I'm the one doing the videos and the students know to send me directly the Marvel superhero of the day each time. And there were fewer students from other schools that probably felt comfortable enough sending it to me or their teachers. So I've taken anyone that's from a school that's not Montview, and I'm going to put them in the wheel, and we're going to see which one of them wins a $10 gift card at the last drawing of the year. Okay, so here's the wheel. Maybe. There we go. I noticed I put Jalen Bounds and Sean Lynch on there twice. They both won twice, so we'll go ahead and include them twice. So here we go. One of you guys wins a $10 gift card. Sorry, everybody at Montview, you guys had opportunities to win too. All right, let's see. There you go, Sean Lynch. I believe Not 100% sure, but what school is Sean Lynch from? Well, Sean, you know who you are, and you know if you won. And so please go ahead and send me a message and just send me an email. Or send your teacher an email and they can send me one. But congratulations, Sean Lynch. I'll get you a $10 gift card to Amazon. Congratulations. Thanks for playing Marvel Superhero of the Day. I also want to celebrate all of you guys. If you're watching this video today, you've been through 20 different modules, and whether it is Thursday, May 21st, or it's later, you guys have been working really hard on something like a brand new situation, and I'm really proud of you guys for making it this far. So congratulations to you for all the work that you've put in. Hopefully you've learned some math along the way as well, and are getting ready to take a well-deserved break for the summer. So we do need to go ahead and get one more lesson taken care of today, and it is still involving our 30, 60, 90 triangles. Remember, in the 30, 60, 90 triangles, the 30-degree angle leads over here to a short leg opposite of it. The 60-degree angle leads to a long leg opposite of it. And then, of course, the part that doesn't touch the 90-degree angle is the hypotenuse. Really, a 30, 60, 90 triangle just comes by slicing an equilateral triangle in half, straight up in half, and that's why we have the equilateral triangle there on the words. And then we're going to continue to use proportions to find the missing sides. So let's just take a minute here to complete these notes. Remembering just to label these sides here. Obviously, this side is the hypotenuse, so label that along with me here, please. This side is the long leg. The legs are the ones that touch the right angle, and so we call this one the short leg. Okay, so have those labeled so that you can just kind of get those names continued to remember. You might want to abbreviate the hypotenuse as HYP, the long leg as LL, and the short leg as short leg, SL. Okay, and the three key pieces of remembering this is that the short leg is, sorry, get up here, half as long as the hypotenuse. So just that relationship between the short leg and the hypotenuse is key there. Short leg is half the hypotenuse, so write that one down. And then the hypotenuse, so I have that up here, the hypotenuse is twice as long as the short leg. That's that key relationship there, that the hypotenuse is twice as long as the short leg, and the short leg is half as long as the hypotenuse. Finally, when we want to talk about the long leg, that's the trickiest one, but the long leg is going to be compared to the short leg, and it is basically square root of 3 times as long as the short leg. So that long leg is square root of 3 times as long as the short leg, which makes for a little bit of a weird relationship, but gets us to practice all those cool radical relationships that we learned throughout e-school. Cool. All right, so what I've found is that students will sometimes start using these cool properties of 30, 60, 90 triangles on triangles that aren't really 30, 60, 90 triangles. So the first part of today, I just want to make sure we can recognize if something is a 30, 60, 90 triangle or not, because if it's not, we can't use these cool properties that we've been learning. So first of all, is this a 30, 60, 90 triangle? Yes or no? Circle that, and then tell us why or why not. It may look like one, but we are going to have to say no here. We have to say no because there are no measures on the angles or sides. So we have no way of knowing if it is a 30, 60, 90 triangle. No measures on the angles or sides. So we just have really no way of knowing. So we really can't tell. Okay, so we wouldn't be able to use the special properties of 30, 60, 90 triangles here. We just don't know if it is one. What about this one? Is the blue triangle below a 30, 60, 90 triangle or not? Take a second and then circle one yes or no. Okay, yes it is, because if you notice, all three sides of this original triangle were 10. And so as we remember, when we made our first 30, 60, 90 triangle, we made it by taking an equilateral triangle and slicing it in half. So that's what just happened here is that equilateral triangle of 10, 10, and 10 got sliced in half. So now we have um, this is a 60-degree angle because in a 30 in a equilateral triangle all angles are 60 degrees. So this is 60, this is 90, and up here this is 30. Plus we have the hypotenuse of 10, and as you can tell, this shorter side here will be a short leg, and that comes by cutting a 10 in half, and so that will be 5 right here. So yes, this is a 30, 60, 90 triangle because uh, that is what you get when you cut a equilateral, so equilateral triangle in half. Sorry, I'm typing so slow today. All right, let's check this one out. Is this a 30, 60, 90 triangle? Yes or no? Hopefully you can see, yes, it clearly is. You have a 30-degree angle, you have a 90-degree angle, and that means the other one does have to be 60 degrees because you only get 180 degrees in a triangle. And so, yes, there is a 30-degree angle. Wow, typing is just terrible tonight. There's a 30-degree angle and a 90-degree angle. So the other one is 60. Okay, so yeah, that's a 30, 60, 90 triangle. Let's look at this one. Is this a 30, 60, 90 triangle? Yes or no? Why or why not? What do you think? I say yes, it is, because when you look at it, our hypotenuse of 12 is twice the short leg of 6. And if that's a relationship, then we do have a 30, 60, 90 triangle. Yes, because the hypotenuse is twice as long as the short leg. Okay, and that relationship we talked about up above, when the hypotenuse is twice as long as the short leg, that comes from a 30, 60, 90 triangle. Okay, and then lastly here, I think lastly, is this a 30, 60, 90 triangle? Yes or no? No, it is not. Okay, because the long leg is supposed to be square root 3 times bigger than the short leg. But it's in this situation, it's actually twice the short leg, if you can tell, because the long leg is 2 times bigger than the short leg. That means it's not a 30, 60, 90 triangle, because in 30, 60, 90 triangles, the long leg is supposed to be square root of 3 times bigger than the short leg. Then it's not in this situation. So this is not a 30, 60, 90 triangle, which means we would not be able to use the 30, 60, 90 properties here. All right, so we're going to do a few more together here. Welcome back, Thelma. We've already used Thelma actually in some earlier problems, but now we're going to go with this. So find the perimeter of an equilateral triangle with a height of 12. So again, we're back to that equilateral triangle, and we want the perimeter. Well, the perimeter is the distance around the outside. So what I'm going to need is to know, I'm going to need to know either the hypotenuse of, we'll kind of highlight this triangle in purple here. So when you look at this triangle in purple, we have 60, we have 90, and we have that the last angle has to be 30 because, again, you only get 180 degrees in a triangle. So if we already have 60 plus 90 is 150, there's only 30 degrees left to form a triangle. So this is a 30, 60, 90 triangle. Plus, again, we wrote up above that you get 30, 60, 90 triangles when you cut equilateral triangles in half, and that's what we did. So this is a 30, 60, 90 triangle. So we can just go ahead and get a Thelma here, or maybe some of you guys are good enough at drawing them now that you don't have to get your Thelma, but I'm going to go ahead and draw Thelma right here in the same orientation as the purple triangle, the 90-degree angle in the bottom left. And remember with Thelma here, the bottom or the short leg is 1, the long leg is square root of 3, and the hypotenuse is 2. So that's what we get when we're working with Thelma here. And so let's go ahead and set up our proportion. I want the hypotenuse, honestly, because if I know the hypotenuse, I'll call that x, then I can find the perimeter of this triangle, because if the hypotenuse of this purple triangle is x, then the other side over here will be x, and the bottom will be x as well, because they have told us this is an equilateral triangle, which means all sides are the same. Okay, so let's just find the hypotenuse. I'm going to go with 12 over x equals, and actually I want some more room with that, so I'm going to move that. I'm going to go with 12 over x equals, so 12 is the long leg, x is the hypotenuse. So let's go with long leg over hypotenuse here, which is square root of 3 over 2. So now we're just ready to go ahead and cross multiply. 12 times 2 is 24. X times square root of 3 is x square root of 3. Now to get x by itself, we are going to divide both sides by the square root of 3. It cancels it out over here, and it leaves us with 24 over the square root of 3 here. Now here's another good reason why we don't want square roots in the denominator, because we're going to have to add this x up 3 different times, and it would be pretty tough to do with a square root of 3 in the denominator. It'll be easy once we get rid of that. So let's go off the side here. We don't want any square roots in our denominator, so we're going to multiply top and bottom by square root of 3. We get 24 square root of 3 over, remember, again, it's the square root of 9, but the square root of 9 is really just 3, so we got 3 there. And we can divide that. That does equal, the 24 divided by the 3 there, does equal 8 square root of 3. So really we just found out that the hypotenuse length is 8, nope, I don't want that color, I was going to use purple, is 8 times the square root of 3 equals x. So if our job is to find the perimeter, we're going to have to add 8 square root of 3 for that side, plus 8 square root of 3 for this side, plus another 8 square root of 3 for the bottom side. And that is going to leave us with a perimeter. I'm going to kind of draw a little box here to indicate that now we're focusing on the perimeter over here. The perimeter will equal 24 times the square root of 3. So that is the perimeter of this one, because we found out that one side length was 8 times the square root of 3. All right, next one here. Now it wants us to find the perimeter of a 30, 60, 90 triangle with a hypotenuse of 16. So let's draw it first because nobody drew it for us. So I'm going to draw a 30, 60, 90 triangle. Try to be really careful to make sure that one leg is clearly shorter than the other leg. You don't want to have it looking something like this. That looks a lot more like a 45, 45, 90 triangle. You really want to be careful and have one short leg and one long leg. So the short leg, we don't know. We can call it x if you want to, and the long leg we can call y. But the hypotenuse we know is 16. So let's go ahead and set up Thelma here to join the triangle we've got here. And so Thelma, we know when her short leg is 1, long leg is square root of 3, hypotenuse is 2. So if we want the perimeter of this triangle, we're going to need x and we're going to need y. So let's go ahead and find both of those. I'll set up a proportion. I'll go 16 over x, which is the hypotenuse over the short leg. So that should equal the hypotenuse over the short leg in Thelma here. So that's 2 over 1. Cross multiply, we get 16. We get 2x. We divide both sides by 2 to get x by itself. So x equals 8. So the short leg is equal to 8. Now we need to find the long leg. The long leg, we can go with y. Yeah, that's fine. We can go with y over 16. No big deal. If I go with y over 16, that means I have put the long leg over the hypotenuse. So long leg over the hypotenuse. So you do the same thing for Thelma here, and that will be long leg of square root of 3, that's her long leg, over the hypotenuse of 2. We cross multiply to get 2y equals 16 times the square root of 3. And then we divide both sides by 2 because we want y by itself, and we're left with y equals 8 times the square root of 3. All right, so now for our perimeter, we need to add all three sides. So the perimeter will equal the 16, which was the hypotenuse we were given, plus the long leg, which we found out was 8 square root of 3, plus the short leg, which we found out was just 8. If you remember right, we can combine the 8 and the 16 for a 24, but the 8 square root of 3 has to stay separate. And so that is our perimeter of this triangle using our 30, 60, 90 properties. Okay, pretty challenging, but you can do this. You got all you need. And you can ask your teacher for help if you need to. All right, trickiest one here. This is probably the hardest problem of eSchool, and you're going to be able to get it no problem. It's going to be great. But look what's happened here is they've brought in a 45, 45, 90 triangle as well. I'm going to highlight that one in green. So notice that our job is to find x, y, and z. Well, x, if you can tell, is both the short leg of a 30, 60, 90 triangle as well as the hypotenuse of a 45, 45, 90 triangle. So we've got the two different situations here. We got to use a different model triangle for each. So we got to use both Frank and Thelma here. Now some of you guys are good enough where you can do a little bit of this without even setting up the proportions maybe, but some of you guys will need to set up the proportions still. So let's look at the two different triangles we've got. I'm just enjoying coloring right now. You're probably not enjoying that, so fast forward my coloring. All right, here we go. So let's find x first because the only number we have is 6. 6 is in the 45, 45, 90 triangle, and, and so is x. So we can use that to find x. We don't know anything about the 30, 60, 90 triangle, so there's nothing we can do yet. So we're going to have to use the green triangle first. So let me go ahead and set up a Frank, if you remember Frank, next to this one. So a Frank of 45, 45, 90. Remember, both legs are the same, and the hypotenuse is square root of 2 times as long as the legs. So some of you may know x already, but if you don't, let's just go ahead and set up a proportion. We'll go hypotenuse over leg of the green triangle here. So hypotenuse over leg equals hypotenuse over leg of Frank. Oops. So then all we need to do now is to cross multiply. X times 1 is x. 6 times square root of 2 equals 6 times the square root of 2. Easy enough. We have our x. 6 times the square root of 2. Okay. Which side do you want to find next? I'm going to go with y because if you notice, we've got a 30, 60, 90 triangle here with y. Let me go ahead and draw that in orange. And we've got boom, boom, boom. I'll draw a little version of Thelma here. Thelma is a 1 as her short leg, 2 as her hypotenuse, and a square root of 3 as her long leg. So now that we know that the short leg is, what did we say it was? 6 times the square root of 2. That's what x equals, is 6 times the square root of 2. Whoa. We can go ahead and put that, just put 6 times the square root of 2 is our short leg. So if we want to find y, I'm going to go ahead and go with short leg over hypotenuse of the triangle we have here, which is 6 square root of 2 over y. And then we'll do short leg over hypotenuse for Thelma, which is just 1 over 2. 1 over 2. We cross multiply. We get 12 square root of 2 equals 1y. And we're done with y. Y is 12 times the square root of 2. Now all we got to find is z. So we got 12 square root of 2 right there. So let's do one more proportion. And this one will be a little bit more challenging, but not too bad. Because I'm going to go with short leg over long leg this time in the pink triangle. So short leg is 6 square root of 2. Long leg z, we don't know. It's a z. Then we have to do the same thing. We have to use our Thelma here. Her short leg was 1. Her long leg is the square root of 3. So now we'll cross multiply. If you can see that, we're going to cross multiply and we'll get 6 times the square root of 6, because the square root of 2 times the square root of 3 is the square root of 6. We multiply inside times inside, outside times outside. There's really no number outside the square root of 3 right here. It's kind of like a 1. So we get 6 square root of 6 equals just z. So then we have 6 square root of 6 for z. That's pretty nuts, guys. And if you stuck with us that long, I'm really, really proud of you. There's going to be another problem like this in the independent practice, exact same kind of idea, and then another one in the mastery check too. So I know you can do that. But the key idea is to use your Thelma, set her in the right direction so that you can just set up a proportion and find the missing sides. Thank you guys very much for this. Again, like I said, there is going to be a very similar problem here, but this one actually just has two Thelmas instead of a Thelma and a Frank. And then this one here is very similar to the first problem we did in the guided practice, and then, or the second problem we did in the guided practice. And then this one is just kind of fun. It's this dog walking up over this ramp. All really you need to do is to find this length by using a Thelma, kind of setting it up here, and then adding this length, which is already a 12, and then finding this length, which will actually be the same as that one, and just basically add up the whole distance the dog walked. And with that, once you're done with that, you can do the mastery check, and you'll be done with eSchool for 2020. Well, not all of 2020, but the spring of 2020. All right, guys, have a great day, and it's been great working with you if you don't end up needing to watch the other video. Have a nice summer.